Important to remember the following when differentiating. Okay, you have to remove brackets, divide lines, and root signs, and get your terms into a form where you can clearly see the sign, the coefficient, the variable in the numerator with the exponent before you are able to apply your power rule or your rule for constants to each term of your expression. Okay, all right, so let's jump in and just go back to something simple that we were talking about last week. We're not going to hang around with this too much because I want to get on and do the more difficult questions with you. If they give us an expression like x to the power of 4 plus 6x plus 7, and they ask us to find the derivative of f, we can see that every single term is written in the way that we want it. So sign, number, variable, variables in the numerator, and our exponents are clear. So that means we are ready to find the first or the derivative. So we would write f prime x, and then we would apply our power rule to every single term. So in front of this x to the power of 4, there's an invisible 1. So we'd say 4 times 1 gives us 4, write down our x, and then we would take 1 away from our exponent. And we would do the same thing over here. We would take that 1, we'd multiply it by positive 6, and then we would take 1 away from the exponent. And then anything that has, or any constants, should I say, like 7, for example, this will have a derivative of 0. Okay, so just to recap from last week in what we would do in these sort of situations, what we didn't talk about was removing brackets. It's really quite simple. So what I'm trying to emphasize here more than anything else is the notation rather than anything else. Please note that I am not writing f prime x, I'm writing f of x while I remove my brackets. So if I'm squaring a bracket, remember, this means that I need to multiply the bracket by itself. So essentially what I'm doing is FOIL. So that's going to leave me with 16x squared minus 12x plus 9. And now I can collect together my like terms. So that would leave us with 16x squared minus 24x plus 9. Now I'm ready to find the derivative. Okay, each term is written sign, number, variable, and I can apply my power rule to every single term. Okay, so that would leave us with 32x minus 24. Okay, so I just wanted to go through that so that you've seen all of them, especially when it comes to removing brackets. We spoke about divide lines and root signs last time. And as I said earlier, we're going to do slightly more difficult questions on those this lesson as well. Okay, so when it comes to removing brackets, there's removing brackets and then there's removing brackets. Okay, so if you have a look, question A is really very simple. Question G and question N become a lot more difficult when it comes to removing brackets. Okay, so question A is very similar to what we saw in this example over here. Question G is a little bit more difficult because it involves a root as well as removing brackets. Okay, so I'm going to do G as an example, and then you guys are going to try either question A if you're not feeling very confident, or you're going to try question N if you are feeling confident. Okay, so the first thing that I'm going to do is I'm going to keep my notation because I'm not differentiating. I'm just squaring my binomial. So I'm going to write my brackets out. That gives me x squared minus. And what I'm going to do with this root, how can I write it so that I have a rational exponent? Can anybody tell me? How should I get rid of my root? What should I write in place? I want to get rid of that root sign, and I want to write it with a rational exponent. How would I do that? Into causal, how would I write it? You're welcome to unmute and speak into causal. I can't hear you, Ntokozo. I don't know if anybody else can. Yeah, I see you're unmuted. I'm just having a look. I can't hear you though.
I can't hear Ntokozo either. Ntokozo, you can
Okay.
just sort of go into the mic because I see you have audio going on there. The problem is that we can't hear you. So either is your speaker that is not working, your device, but also just try to log out and in again. Most of the time that solves it, but maybe not. But just try that because we can't hear you. Or put your questions on the chat or your answers.
There we go. So Caleb has put a suggestion onto the chat and has said that we would write it as x to the power of 1 over 2. So that is correct, Caleb. That's exactly what we would do. Close our brackets, and then we're going to repeat our brackets like this, because that's just easier than trying to square a binomial. Please note how I'm keeping my notation and my square brackets because I'm not taking the derivative. I'm removing the brackets before taking the derivative. Okay, so when I multiply x squared with x squared, I end up with x to the power of 4, because when I multiply like bases, I add my exponents. Now when I do the outer part of FOIL, I'm going to end up with minus x to the power of, multiply like bases, you're going to add your exponents, so that would be 2.5. So that would be 5 over 2 minus x to the power of 5 over 2. That's my inner terms. And then last times last would give me plus x, like so. Again, I'm not dropping my differential notation. I'm keeping it there, and now I'm just going to collect my like terms together. So this will give me minus 2x to the power of 5 over 2 plus x. Now am I ready to differentiate? Yes, I am. Okay, so I'm going to drop my dx, I'm going to drop my hard bracket, and my final answer is going to be 4x to the power of 3 minus 5x, take 1 away, so that would leave me with 3 over 2 plus 1. Okay, Amahle, I see your hand is up. Do you want to ask a question? Screenshots, everybody.
Hi, Amahle. You also can't talk?
Know why there's people that can't talk today. Know what's going on with
That's really weird.
it is, isn't it?
Amahle, can you talk on your side? Why can Julie and I can hear each other, but we can't hear you guys?
Yeah, it's very strange.
Sorry, just to try and see, Apiwe, can you please unmute on your side and talk to us? I just want to see something. Sorry to put you on the spot, girl.
No, it's fine.
Oh, there we
There we
go.
go.
Oh,
Okay,
lovely. So we
nice,
can hear
Apiwe.
Apiwe.
So we
Okay,
can
thanks.
hear Apiwe. I think it should be network Amahle on you guys' side. It could be that this load shedding and everything else is just messing around with our Wi-Fi's and datas.
Yeah.
But now we know that our problem is solved, so we can continue.
Okay.
Sorry to tell you.
All right. No, that's fine. That's fine. Okay, so now you guys have got an opportunity. You can either try question A, which would be very, very easy, or you can try question N. Question N is obviously a little bit more difficult. Give that a bash now. If you've got any problems, then ask either Yolanda or I for assistance, please. Amatle, because they were asking you to square the binomial. Can you see over here? I'll just highlight it for you. Can you see here they've got brackets around the binomial and it's been squared. So they're asking you to do FOIL. Okay, Amatle? Okay, so everybody else continue working. All right, Palesa, I'll go through it one more time for you. I was just talking about how everybody else just continue to work. I was just talking about what happens when we've got brackets and we want to differentiate. So we've got to remove our brackets either by, we've either got to remove brackets by distribution or we've got to remove brackets by FOIL. Okay, so if we are doing FOIL, then it's a binomial times a binomial. So I had done question G as an example with everybody. The first question that I asked was how would, because remember we've got to get rid of root signs as well. So the first question I asked is how would we alter the way in which we wrote root x so that we could write it with a rational exponent? And Caleb said, why don't we write it as x to the power of a half, which is perfectly correct. So that is exactly what we did. So getting rid of the root sign. And then I just did FOIL. So first outers, inners, lasts. So x squared times x squared is x to the power of 4. Then x squared times x to the power of, negative x to the power of a half gives us minus x to the 5 over 2, as does the inner terms. And then last times last gives us plus x. Remember, when you multiply like bases, you add your exponents. Then I collected my middle terms and I got minus 2x to the power of 5 over 2. And now I'm ready to apply the derivative. So can you see I kept my dx and my hard brackets all the way through, and then when I applied my power rule, that's when I dropped the notation in the square bracket and I applied the power rule to every single term. Okay, so the power rule means multiplying the exponent with the coefficient and then taking 1 away from the exponent. Okay, so Palesa, that's all you've missed. Now everybody is trying either question A or question N. N is better. And then we're going to talk about the answers that we've got. Cool.
Ntando, is that another hand to ask, or yeah, do you have a question? You can ask, you can unmute if that's another question. Oh, Ntando wants to try letter A. Okay, Ntando, so I think Teacher Lee is just giving everybody a chance to have a try at it. And then when she's ready, she will definitely call on you.
Absolutely. In the meantime, why don't you give N a try? That's fine, Caleb. Okay, so there's a whole bunch of you that are done. Okay, and Ntando, what did you do for question A? Tell us.
Hi, Ntando. It's now time to shine. You need to teach us. And Ntando, you have to unmute on yourself. So you are definitely muted, but you can press the unmute button and then you can talk to us. Here we go.
Good afternoon.
Good afternoon,
Ntando.
Ntando.
I said dx
Mm-hmm.
open bracket and 2x squared
Mm-hmm.
minus 8x.
Minus 8x.
Yes.
Why minus 8x?
I took the first 2x and multiplied it with the 4 on the next bracket.
But the 4 is positive. So you've got positive 2x multiplied by 4, so that should be plus 8x, not minus 8x.
Okay, then.
Okay, all right. Keep going, and then on the inner terms, you should end up with?
I had minus 3x
Lovely.
plus 12.
Minus 12, a negative times a positive is a negative.
Okay.
Okay, all right. And then
I said dx again.
good,
Then I said 2x squared.
good.
Then I added the like terms and I got 11x squared.
Okay, but you wouldn't get 11x squared here. You've got 8x minus 3x, so that would leave you with plus 5x. And then your last term would be negative 12. Okay, good. All right, keep going. So now based on what I've got here on screen, can you tell me what the final answer should be?
The final answer is 4x.
So you're just going to write equals. So you've got 4x. Yes, good.
Plus plus 5.
That's it. Well done. Very good. Perfect. Well done. Lovely, Ntando. That's 100%. Okay, excellent. So if you did question A, that's the answer that you should have had. Anyone want to offer to do N for us? Matsetanati. Did anybody try N? Okay, let's see who's got a hand up here. There's a few people. Nhlanhla. Okay, Nhlanhla, go for it.
Okay, so for n, I said dx
Mm-hmm.
Brackets square root of x over 2
Mm-hmm.
Plus 2 over the square root of x.
Mm-hmm.
And then I put it in brackets, and then I put another I put the other in brackets, and I put the other in brackets.
Okay, so you repeated the bracket, in other words. Okay, what you can do here in Nhlanhla and everybody else who tried this question is that you can, in order to save yourself a little bit of time, what you can do is you can actually write the root x as x to the power of half at the same time as you expand the brackets.
Oh, okay.
Okay, just to save yourself a little bit of time if you want to. So what I'm saying is over here, you can write that as x to the power of a half, and you can do the same thing at the bottom over here. You can write that as x to the power of a half. Okay, and then it just kind of helps you to do two things at once rather than write everything out again. But it doesn't matter. If you didn't do this and you did it in the next line, it doesn't matter at all. So I'm just doing that for you. Okay, and then what did you do after that? You want to take over from here?
Ma'am, wait, the thing is I didn't put it like that, ma'am. I just left it in the square roots.
Okay, so did you not get rid of the square roots at all?
I did at the end.
Oh, okay. All right. Okay, so because the thing is that in you did at the end, it's easier for you to do it earlier rather than later on. Okay, so because then when you FOIL, you can see exactly what it is that you're working with. So my suggestion to you is if you're going to get rid of roots and stuff like that, get rid of them in the beginning. Get rid of the roots and the divide lines in the beginning,
Okay.
rather than at the end. What did you get as your final answer, incidentally?
I got 1/4 minus 4x to the power of -2.
That's perfect. Okay, that's perfect. That's exactly what you should have got. That's exactly what you should have got. So again, it doesn't matter. It just makes life easier for you if you do that sooner, but that was absolutely perfect. That's exactly the right answer. Okay. All right, well done. Okay, so just to run through that quickly, because I think I'm probably confused, well, not confused, but Nhlanhla just did it slightly differently to the way that I did it. What I would have done here is I would have, as I had said, I would have got rid of my roots. I would have also at this point written each term. So I would have written x to the power of a half over 2 is 1 over 2x to the power of a half. And then what I would have done with my second term is I would have written that as 2x to the power of minus 1 over 2, like so. That's what I would have done in my first step, by the way, just to make life easier for myself. As I was saying earlier, it just helps you to get your answer in fewer steps rather than in lots and lots of steps. Okay, so what I've done here is I have removed the roots and I have removed the divide lines as well. Okay, we're still not ready to drop our dx notation. Now, when we multiply like bases, we add our exponents. A half times a half is going to give us a quarter, and that would be a quarter x, because a half plus a half would be 1. Then when we multiply our outer terms, we're going to end up with 1x, and then when we multiply like bases, we add exponents, so that would just be to the power of 1. Same thing with our middle term, that would be x, and then our last term would be plus 4x to the power of -1, like so. And then we have foiled out our brackets. Okay, and then dx over here, this would leave us with, we've got a quarter x plus another x plus another x. So the first 3 terms are all like terms. So that means I've got hang on a second.
More like 9/4x.
Hang on a second. I don't know if I just want to double check myself here. So when you've got a half times a half is a quarter, then a half plus a half would leave us with 1. Then you've got a half times 2, which is 1. And when you multiply like bases, you add exponents. So a half plus a negative half would be 0, wouldn't it?
Yeah.
So sorry. Those middle terms are not supposed to be x's. That's supposed to be a 1. Sorry, this is supposed to be a 1, not an x. Okay, so that should be 1, and that should be 1 like that as well. Okay, so that means that we're going to end up with 1 over 4x plus 2 plus 4x to the power of -1. And now we're ready to take the first derivative. So that means that we're going to end up with 1 times a quarter is a quarter. And then the 2 would obviously become 0. And then we would end up with 4 minus 4x to the power of -2. Okay, like so. All right, matrix, all good. Any questions?
Take screenshots.
Okay, so Nhlanhla's happy. Okay, so if there are no other questions, then I'm going to move on. If you guys are coping with that, then it means that you are doing very well.
Yeah. Are you guys
Good,
sure though? Because
absolutely.
I saw your answers, some of your answers there. But yeah. No, I guess we are all good. They're like
Okay.
got it.
All right.
Everybody's doing thumbs up.
If that's great, if you've got that, then you're well on your way. Okay, so now what we need to do is we need to talk about what happens when we've got monomial denominators. So in other words, they give us a function statement, and then we've got a denominator that is a single term. Okay, so for example, here they want us to find the derivative of x squared minus x minus 6 over 2x squared. All right, so what we would need to do in a situation like this is we need to split the numerator over the denominator. Okay, so I'm just going to write that on the side for you. We're going to split the numerator over the denominator. Numerator. Okay, and then we're going to use our normal exponent laws. When we divide like bases, we subtract our exponents in order to simplify. Okay, so in the situation here, we'd end up with dx square brackets, and then what I'm going to do is I'm going to put x squared over 2x squared minus x. I'm going to put that over 2x squared minus 6, and I'm going to put that over 2x squared. That's what I mean when I say I'm going to split the numerator over the denominator. The reason I'm allowed to do this is because if I have something like 1 plus 2 plus 3 all over 7, I'm allowed to write that as 1 over 7 plus 2 over 7 plus 3 over 7. That's essentially what I'm doing. Okay, and now I'm going to simplify. Notice again, matrix, I do not drop my dx notation because I'm not differentiating. And I'm going to simplify each term inside my hard brackets. Okay, so when I simplify the first term, I'm going to end up with 1 over 2 because x squared divided by x squared is 1. As far as the second term is concerned, I'm going to end up with 1 over 2. When I divide like bases, I subtract my exponents. So that leaves me with x to the power of negative 1 minus 6 divided by 2 is 3. And then I'm going to take this x squared to the numerator, and I'm going to remember to change the sign. Okay, now I'm in a position where I'm ready to take the derivative. The first term is going to be 0. The second term is going to be positive because it's negative 1 times negative 1 over 2. So that will leave me with positive 1 over 2, x to the power of negative 2. A negative times a negative is a positive. So that will leave me with positive 6, x to the power of negative 3. Okay, any questions? Ntando?
So, Madam, you said the first, like 1 over 2 is equal to 0.
Yes, because the derivative of any constant is 0.
Oh, okay.
Okay, so that's why the first 1 over 2 became 0, and I only have 2 terms in my answer. Okay, no problem. Lucinda, do you want to ask a question?
No, ma'am, can you please go down and I want to screenshot the question. I didn't get the question.
Oh, okay, so you just want me to go up a little bit. Okay, and Lino? Do you have a question? Hi, Lino. I'm struggling to hear you a little bit. Can you just say that again, please?
Oh yes, and I just wanted you to please repeat me just
Lino, Shem, your
Oh man, I wanted you to please repeat the equation because I had the network issue.
Okay, all right. What I'd like to do is I'd like to give people that did understand this question an opportunity to try the next two questions, and then I'll go through it again. So if you understood example number 4 and you're ready to try something similar or a little bit more difficult, then you're welcome to try either of the two questions on the right-hand side, okay? And I will go through example 4 again. All right, if you want to try something that is a bit easier, question E is a little bit easier. If you want something that's a bit more of a challenge, then you can try this question over here with a little red dot. Okay, then at least hopefully that kind of keeps everybody busy. All right, if you were struggling in understanding this question, all right, this is what we do when we have a monomial denominator. We are going to split the numerator over the denominator. So each part of the numerator is written over the denominator. So you can see in my first term, I've got x squared over 2x squared. In my second term, I've got minus x over 2x squared. And in my third term, I've got negative 6 over 2x squared. What this allows me to do is it allows me to simplify each fraction, all right, using my exponent laws. All right, so when I divide like bases, I subtract my exponents. Okay, so in front of this x squared in the numerator over here is an invisible 1. That's why I've written it as 1 over 2. X squared divided by x squared is 1. So that's why 1x squared over 2x squared becomes a half. Right, in the second example, in the second part, in second term, I've also got an invisible 1 over here. So I've separated the 1 over 2 from the exponent. X divided by x to the power of 2. When I divide like bases, I subtract my exponents. 1 minus 2 is negative 1. So that's where the negative 1 in the exponent comes from. Okay, the last term, I've got negative 6 divided by 2 is negative 3. And when I move my x to the numerator, I change the sign of my exponent. So that's why I've got x to the power of negative 2. Then in my third line here, I drop my dx and my square brackets because I differentiated. The first term is a constant, so it becomes 0. And then my second term, I'm applying my power rule. So first of all, a negative multiplied by another negative is a positive. 1 times a half is a half. Then I have to take 1 away from my exponent. So minus 1 minus another 1 gives me minus 2. And then I did the same thing with my last term. A negative times a negative is a positive. 3 times 2 is 6, and then I have to take 1 away from my exponent. So minus 2 minus 1 leaves me with the minus 3 that I see over here. Okay. Are there any further questions, or you guys ready to try either E or the little question with the red dot? Are we all good to go? No problem.
Are we ready? On that team, are we ready? I see you and I are load shedded. I can't even see myself either. Hopefully you're sitting at the table and you are trying it. Hey, Unati. E and the red dot one. The green dot and the red dot.
Yes.
Let's do, guys. Let's do it. Let's do this. Yay, Amahle, can you then, do you want to try then to raise your hand so I can unmute you? That's the only way we can test if we can hear you. Because if you can hear us, we should be able to hear you. Okay, you have to unmute on your side. Still no wins, Amahle. Let's keep trying. I'm not sure what you need to do. I'm also lost. Dando, is that a hand to ask a question? You can unmute. Yo, these people are fast.
They are, aren't they? Okay, so I think Ntando wants to do the one with the green dot. Okay, Ntando, go for it. Tell us what you did.
Ando, we're ready for you. You can take the stage whenever you're ready.
Oh, okay. I said GT,
Mm-hmm.
then I open a bracket. I said T to the exponent 3 divided by T
Lovely.
minus T squared divided by 2
Good.
plus 1 divided by 2.
Lovely. Well done.
Then
Keep
I
going.
bring down the GT.
Mm-hmm.
Then I open a bracket and say T squared
Yes.
minus T
Mm-hmm.
plus T
Plus
T,
T
yes,
to the power of.
negative 1.
Good. Well done. Very nice.
Then I said the final answer I got T2 minus,
Did you get 2T?
yes,
Uh-huh. Minus.
T
Minus.
T,
Minus 1. So here you'd have minus 1 because you'd say 1 times negative 1 would give you 1. And then your last term would be minus T to the power of negative 2. Okay, so you did that really nicely. It was just here in the middle where you seem to have got a little bit stuck. Okay, so remember in front of your T there's an invisible 1. So 1 times negative 1 gives you negative 1. Then you're going to take 1 away from your exponent. So your T won't be there anymore. And then for your last term, a negative times a positive is a negative. Write down your T and then take 1 away from your exponent. Okay. Well done, Tando. That was good. That was excellent. Well done. Oopsie daisy. Hang on a second. Sorry, guys.
We got this, my people. Well done, you guys. I hope you are marking your work and you are checking where you went wrong so you can find the corrections.
Sorry, I don't know what happened there with my screen. Just give me 1 second. There we go. Okay.
We are back.
We are back. Okay. Then as far as this sort of slightly more difficult question was concerned, Caleb, do you want to try this one? I saw your hand was up earlier. You got the same answer. Good. Well done.
Santa might want to try it.
Inhlantla wants to try it. Okay, Inhlantla, all yours. Go for it. And this time I won't interrupt. Go for it, Inhlantla. Okay.
For this one, I said y equals 2x to the power of 2
Mm-hmm.
over the square root of x minus x to the power of 1 over 2 over x to the power of 1 over 2.
Okay.
And then I said plus 5 over the square root of x.
Okay. So, Inhlantla, why did you change these ones in the middle? Why did you change this one and this one, but not these? It's not a problem. It's just if you pardon?
I changed them on my second step.
All right, that's fine. Okay, all right, keep going.
On the next step, I said 2x
Okay,
to
so
the
again,
power
it's 2x to the power of?
2
Uh-huh.
over x to the power of half
Uh-huh.
minus 1
Okay.
plus 5 over x to the power of half.
Sure. Okie dokes. Keep going.
Okay, so for this one, I said 2x to the power of 3 over 2
Lovely.
minus 1
Mm-hmm.
plus 5 x to the power of negative a half.
Lovely, Nhlanhla. Well done. Very nice. Next step.
Okay, and the next step, I said dy over dx.
Good.
I got 3x to the power of half
Uh-huh.
minus 5 over 2x to the power of negative 3 over 2.
Excellent. Excellent, excellent, excellent. Well done. That's very good. Okay, very nice, Nhlanhla. Well done. I could not have explained it better. Okay, so if you did what Nhlanhla did here, that was perfect. You would get a mark for splitting things up, for simplifying it accurately, and then you would get a mark on each of those terms like that. Okay, so if you did this like Nhlanhla, very well done to you. Is everybody happy with that? Can we move on? Any questions? Sure,
Teddy's
Teddy,
hand
go
is
for
up.
it. Sure,
Yeah.
Teddy, what's up?
Hello, ma'am.
Hi, Teddy.
Ma'am, I just wanted to know about the notation. Is it fine if
Yes.
you kept dy over dx from the get-go?
No, Teddy, it's not. It's not
Oh.
okay at all. You're going to be penalized because you're not taking the derivative until the last step. So you only write dy over dx when you apply the power rule. It's just like when you write f prime x. If you wrote dy over dx the whole way, you're going to get penalized for that. Okay, so that's why I wrote y equals the whole way, because here what you are doing is in these initial 3 lines, you are just preparing the statement for differentiation. You're not actually differentiating. Okay, so whilst you are still preparing the statement, you've got to keep y equals, and only in the line when you apply the power rule, this final line over here with a pink arrow, that's when you write dy over dx. I'm very glad you asked that question, Teddy. Thank you. It is a very common mistake that matric students make. Okay. Cool. All right, so let's move on and talk about binomial denominators now. We've spoken about what happens with monomial denominators. This is, in many respects, I think is a little bit easier, but anyway, let's just whip through it. Okay, so when you have got a binomial denominator, you need to factorize. Okay, so you have to factorize the numerator. And then once you have factorized, you can cancel down, and then you can find the derivative of what's left over. Okay, so let me show you example number 5. I haven't left myself very much space here. Let's just move these down and out the way. If you have a look in the numerator here, I've got a highest common factor. So again, minding my notation every step of the way, I'm keeping the dx in the hard bracket. I'm going to take x out as a highest common factor. That's going to leave me with 3x squared minus 7x minus 6. And then at the bottom, I'm going to change that around, and I'm going to take the negative out, and that's going to leave me with x minus 3 at the bottom. Okay, just so that it makes it easier for me when I do eventually cancel down. All right, now I need to factorize my numerator further. That binomial of the trinomial over here can be factorized. So I'm going to have 3x over here, and I'm going to have 1x over there, and then that's all going to be over minus x minus 3 as follows, keeping my square brackets. Okay, so now I need to think of my factors of 6. That can also give me 7 in the middle. So I'm going to put 3 here and I'm going to put 2 over there. This is going to give me 9x. So I want that to be minus 9x. Plus 2x to give me the minus 7x in the middle. And then plus 2 times negative 3 will leave me with my negative 6. Okay, now that I have factorized my trinomial, I can cancel a factor at the top with a factor at the bottom. Don't forget they've got a negative 1 hanging around in the denominator. So that means we're going to end up with negative x. And then here I've got 3x plus 2. Okay, so now I'm just going to have to get rid of those brackets quickly, and then I can find my derivative. So that's going to leave me with minus 3x squared minus 2x. And then my last step here, matrix, I'm going to drop. So I'm going to just move that down. I'm going to drop the dx, I'm going to drop the square bracket, and I'm going to apply my power rule. Okay, so that's going to give me minus 6x minus 2 will be my final answer. Okay, any questions?
You guys are doing a great job.
You are indeed. Okay, if there's no questions, then there are 2 questions for you guys to try. So either you can try this one over here, or you can try this one over here. Okay, give it a bash. Okay. Cool. Okay, so there's a few of you that are done already. A p where, if I may I ask, is the denominator for the example x minus, yes, minus x times, yes. So what I did is I took out a negative at the bottom, a p where. Okay, so then when I factorize my trinomial at the top, things are in the correct order. Okay, so you can't cancel something like y minus x with x minus y. It's not the same thing. So if you were canceling these two, if you wanted the bottom to look like the top, you would first have to take out a factor of -1, and then you'd end up with y minus x. Now you can cancel. Okay, so the answer would be -1. So that's the idea. Okay. Okay, anyone do the green one and wants to give it a try for us? Ntando, you're on fire tonight. Ntando, go for it. What did you do with the green one? Go for it, Ntando. Don't know why. I don't know if you have unmuted, Ntando. I can't hear you. Oh, there you are.
sorry.
Oh, there we go. Gotcha. Keep going.
I said dx.
DP.
Yeah, sorry.
Okay, it's okay. DP. No
Then
problem.
I opened the bracket and factorized the numerator,
Lovely.
which is x plus 3
Mm-hmm.
and x minus 3.
Oh, are you doing this one? Okay,
Yeah,
hang on. No wonder you, okay, there we go. Okay, sorry. Okay, so you're doing this one. You said x plus 3, then you said x minus 3. Okay, keep going.
then I said 3 minus x.
Okay.
Then I said dx again.
Uh-huh.
Then I wrote the numerators as they are.
Uh-huh.
Then the denominator, I took out the common factor, which is x.
In the denominator.
Which is negative.
That's it, which is negative. Good.
So that the inside the brackets, I can have x minus 3.
Lovely. Well done.
So I cancelled x minus 3.
Yes.
Then I left. Actually, the final answer is negative x plus 3. If I'm not
Okay. So, okay, so inside, so keeping your dx in your squared bracket, the final answer you got is minus x minus 3. Lovely. And now when you take the derivative, what would your final answer be?
it'll be -1.
That's it. Perfect.
Yes.
Well done. Okay, so it would just be
Thank you.
-1. Well done. Very good. Okay,
Thank
so if you, well done, Ntando. So if you did that like Ntando, that's what you would have got. That's perfect. Well done, Ntando. Anybody else do the green one and wants to share their answer?
Oh, and let's not log out, guys. We have a poll to do,
Leanne,
please.
Leanne, go for it. Let's just do this quickly.
So ma'am, I said DP,
Mm-hmm.
then I changed the numerator and said 2p plus 1 in brackets.
Mm-hmm.
And then the other brackets I put p plus 1
Okay, lovely.
over p plus 1.
Good.
And then I have, for the next step, dp into 2p plus 1.
Good. Well done. All right. And
And
then
then
your
my
final
final answer is
answer.
2.
Good. Excellent, Leanne. Well done. Perfect, perfect, perfect. Good job, everybody. That was great. Well done. Nice going, Matrix. Any questions before Yolanda runs the poll?
Oh, sorry.
It's okay.
Yolanda's
It's okay. It's okay.
already
It's okay.
running the
It's okay.
poll.
It's okay. It's okay.
You guys did really, really well.
They did, didn't they?
Lebo, you can
Yes.
ask.
Lebo, you can ask.
Afternoon, ma'am.
Afternoon.
Afternoon. Ma'am, can I ask if, for example, if they say dx, do they mean, okay, for example, if they say 3x squared, y squared, do you only focus on the 3x squared?
Yeah, so you can only differentiate with respect to one variable at a time. So what they can do is they can give you an expression and then they can ask you to differentiate with respect to one variable or to another one. But you can't do both at the same time. Also, your function statement either has to be in terms of f of x equals or y equals or whatever the case is. So they can't give you 3x squared together with a y squared. All right, they won't do that to you. Okay, Lebogang.